Hi, my name's Alan Smith. In this video, we're going to look at the Azure Language Service versus GPT-4o. It's going to be one of a series of webcasts looking at how large language models is not only changing the way we build applications, but also changing the way we solve solutions using artificial intelligence. The Language Understanding service has been around for quite a while, and we can train it to understand utterances, extract intents, and then systems can perform actions based on those intents. And we'll compare this functionality with using a large language model, combined with Semantic Kernel and function calling. And the scenario that I'll be using for the demos is placing pizza orders. So a traditional approach to solving this problem will be using the Conversational Language Understanding service, which was formerly known as LUIS. So with this service, we can create a new project, and I'll name it Pizza Shop, and I'll leave all the other settings as default. The first thing we have to do is define the schema. So I'm going to add an intent called add pizza to order. So when the customer is ordering a pizza, this intent will be recognized. Now to train the model, we need to have some examples of utterances of this intent. So I'll select the add to pizza order intent, and in Notepad, I've got some example utterances. So I'll copy paste these utterances and add them as examples of the add pizza to order intent. Okay, so we've got about 10 examples of the intent, which should be enough to train the model. The next thing I have to do is to define the entities. So I'll define an entity named pizza type, and that will be a string. We'll leave it with the default settings. I'll add another one for the size, and a third one for the quantity. I'll edit the quantity intent and set it to use a pre-built quantity number. So this will recognize cardinal numbers like 1, 2, 3, and so on. Shouldn't matter if they're in text or digits. And I'll add a final entity, which is extra info. So now we've got to go through all of the utterances, and I need to select and label all of the entities in each utterance. Now I've only got 10 utterances here, and only one intent, and you can see that it's a fairly tedious job to perform the labelling on all of these utterances. I've speeded up the video quite a bit, but you can get the idea that this is going to take a long time if we're working with a large data set. So with all of the utterances labelled, I can save the changes and create a new training job that's going to train a model. I'll name the model Pizza Shop 01 and train the model with the standard training. I've speeded up the video, but it takes about 30 seconds to train the model. It's pretty quick. Okay, so the training is complete. We can go into the models and examine the performance. So here we can see in the overview, it's saying we've got 100% for everything. However, it is providing us some warnings that we haven't used enough intent labels. So we couldn't really trust those figures. In order to test the model, I'll need to deploy it. So I'll create a deployment named Pizza Shop Dev and deploy the model to that deployment. So we can now go in and test the model. So I'll select the deployment, and in Notepad, I've got some examples that we can use for testing. So I'll take the first example, and you can see there that it's correctly identified the quantity, the size, the pizza type, and the extra info. And we can test with another example and see that it's getting the correct results. And the same with the third one. And the fourth one as well. So even though we haven't trained this model with much data, it's still fairly accurate at being able to handle these simple utterances. So let's take a look at how we can do the same implementation, this time using a large language model. So here, I'm using GPT-4o, together with Semantic Kernel, and I'm leveraging the function calling functionality. So I've created a simple console application, and the application is going to await the pizza's order method. The pizza's order method is going to create an instance of the kernel builder. I'm then going to add the Azure OpenAI chat completion service. I'll specify GPT-4o as the model, and take the endpoint and key from a configuration class. I'll then add the Pizza Shop plugin to the kernel builder. The Pizza Shop plugin class only contains one method, add pizza, and it takes in the size, the pizza type, and any extra info that the customer has specified. And all the function does is write the method name and the parameters to the console, so we know when the method has been called. I've added attributes to the method. I've specified the name of the kernel function using the Python naming convention, which is typically better understood by the models. And I've also added a simple description for the method. I could also provide descriptions for the parameters, but in this case, I think they're fairly straightforward. Back in program.cs, I'm going to build the kernel, get a reference to the chat completion service, and then define the execution settings. And in the execution settings, I'm setting tool call behavior to auto-invoke kernel functions. And this will mean that the semantic kernel will automatically call any functions that are requested by the model. I've then got a while true loop. I'm going to prompt the user to enter the details for the pizza, and then await the chat completion service, sending in the order details, the settings, and a reference to the kernel. We're then going to print out the response in the console. So I'm not using a chat history here, so the application won't maintain any state between the calls. So let's test the application. I'll use the same test strings as I was using for the language understanding service. Okay, so it's prompting us for the first order. And we can see there that when I asked it, can I get 2 medium supreme pizzas with no olives? You can see that it's made 2 calls to add pizza, passing in the size, the pizza type, and the extra info. When we ask it for 3 large sausage pizzas with extra cheese, you can see that it's made 3 calls to that service. And whichever of these orders I send in, you can see that it's making the function calls appropriately. So we seem to have got very similar functionality here, using a generic large language model without having to train the model. What's also interesting is that I'm not specifying any system prompt. I don't need to provide a specification of what the application should do. The large language model is able to understand which methods should be called based on the information that I'm sending in. So both of these implementations were able to handle these simple orders. But we're just ordering a quantity of one type of pizza and maybe specifying some extra information. But what about complex orders? If the customer would like 3 large veggie pizzas, one with extra olives and one with extra cheese. So let's see if the language understanding model can deal with this case. And here it's picked out the quantity, the size, the type, but it's also picked out the quantity twice for 1. And the extra info is with extra olives and one with extra cheese. And from these entities, it would be hard to understand what the actual order was. Let's try this one. I want a big pizza with lots of toppings. Be creative, but please, no pineapple. And here we've just got the size as big and extra info with lots of toppings. But it hasn't picked up anything about not having pineapple on the pizza. This is another more complex order, where we're asking for several different types of pizzas. And again, it's picking out some pizza types, some quantities, but it's getting mixed up in the language. And this one's more complex. I'm hosting a user group meeting tonight. There's 55 people registered, however we expect 20% no-shows. We'd like to order pizzas for the event. The attendees will be hungry. Some of them may be vegetarian, and others may have allergies. So here it's got 55 and 20 as the quantity, which is really from the number of people and the number of no-shows. And it hasn't picked out any other information. So let's test the same complex scenarios, but this time using GPT-4o with semantic kernel and function calling. So the first example, I'd like 3 large veggie pizzas, one with extra olive and one with extra cheese. And you can see that it's made 3 calls to add pizza. All 3 calls are for large veggie pizzas. The first one has extra olives, the second one extra cheese, and the third one is just the default pizza. So it seems to have handled that order very well. Let's try the next one. I want a big pizza with lots of toppings. Be creative, but please, no pineapple. Now we can see it's called Add Pizza. The size is big, the type is supreme, and the description is loaded with various toppings such as pepperoni, sausage, mushrooms, onions, bell peppers, and olives. No pineapple. so it seems to have handled that case very well. Let's try the third one. And in this example, we're ordering a number of different pizzas, with variations in the toppings. We can see here that we've got multiple calls to add pizzas. We've got the 3 large pepperoni, the 2 medium vegetarian, one with extra cheese, the 4 small margaritas, the 2 large meat lovers, one with extra bacon, and the medium barbecue chicken pizza with onions. So again, the large language model is able to understand a fairly complex order and make the appropriate function calls to add those pizzas to the order. So let's try the last example, the pizzas for a user group meeting. So here, the large language model is going to have to make a decision about how many pizzas to order. We're not specifying that. Okay, so the order consists of 4 cheese pizzas that are vegetarian, 3 pepperoni pizzas, 2 veggie pizzas, and 2 gluten-free pizzas that are allergy-friendly. We can see that it's called the add pizza method for all of the pizzas in that order. So it seems to have got a good variation of food. However, with 55 people attending and 20% no-shows, that will be about 44 people. So assuming we've got 8 slices per pizza and 11 pizzas, each attendee would have 2 slices. The order did say that the attendees will be hungry, so maybe we could do with a few more pizzas in the order. So we've seen that when using a large language model, combined with a framework like Semantic Kernel and leveraging the function calling functionality, we can create an application that can handle much more complex pizza orders. We don't have to spend time gathering data and training the model. And as function calling is a built-in functionality in Semantic Kernel, we don't have to write all of the code to make the calls to the external application, which we would have to do if we were extracting entities in the language understanding service. So we can see that large language models are really going to change the approaches that we take when we're building AI-based solutions.